Okay guys, welcome back. I'm going to go ahead and show you how to pop a window into a 16-foot wall here. My window specs call for a rough opening of 30.5 inches by 24 inches tall. So I'm going to start by cutting out a hole. The hole's going to be a little bit larger um, than that on the vertical axis to account for the sill plate and header. I'm going to put in a rectangle, and this rectangle is going to be 30.5 inches wide. So the width is true, but the height, which is 24 inches, is going to get an additional 7 inches. And that 7 inches is 1.5 inches for the sill plate and 5.8 or 5.5 inches for the 2x6 header. So 24 plus 7 is 31. And it's going to go there. I'll dimension this off the ground. I want it to be 4.5 inches or 4.5 feet to the bottom of the rough opening, which would be 54 inches minus the 1.5 inches that will be the sill plate. You'll see here in a little bit. I'm going to dimension from the left edge to this. I want it to be centered. So half of the wall is 8 feet. And I want that to line up with the center of the window, which is 15.25 inches from the left edge of the window. So that would be, let's see, 96 inches minus that half, which is 15.25. I'll hit enter, and you'll see that 30.5 is pretty nice because it lines up the edge of my rough opening right on the studs, so I won't have to add king studs. That'll be a helpful thing, a little bit of a shortcut. I'm going to go ahead and extrude this drawing, and as a cut, I could have hit cut, or I could just drag it through like that, and you can see I've cut an opening a little bit bigger than I needed. I'm going to go ahead and add some elements here. I'm going to draw on this face. I'm going to draw a rectangle. Always goes back. It's always kind of funny how that works, but I'm going to go here, and I'm going to go 30.5. I'll hit tab and 1.5. So that'll go there, and then I'll dimension that to the top of what is now going to be a jack stud or a cripple stud. I'm going to go ahead, I'll finish the sketch and extrude that. I'm being sure to hit solid. Go to a little bit of an isometric view, and I'll go the other way, and I'll go 3.5 inches with that. So that you can see creates a nice sill plate there for my rough opening. It's supported by this, well, it's a cripple stud now, but it was a stud. I'm going to go ahead and add my 2x6 headers. So I'll draw there on that face. Put a rectangle in there, and that rectangle will go from here to here. 30.5 and 5.5, which is a 2x6. I'll hit enter. I'll dimension that up to meet the bottom of that cripple stud. Again, it's kind of a funny verbiage that we use with building. I'll go in, and that'll go in 1.5 because that's a 2x5 laid on its side. Whoops, I accidentally forgot to make that a new solid. So I'll click new solid and hit OK. You can see that does a little bit better job now. This is 1.5 inches, and the thickness of that is 3.5 inches. 1.5 times 2 is only 3. So traditionally what is done is in between there, we add a 1/2 inch piece of plywood. That way it's nice and flush on both sides as far as a nailing surface for both drywallers and somebody that was sheeting a house. So I'm going to go ahead and draw a rectangle in here. And let's see, trouble picking up my edge there. Not 100% sure mathematically what that should be, so I'll project my geometry to help me lock on here. It's a strange fraction. Sometimes that happens, and again, that's why we measure things. But I better just tab across and hit 5.5 so that I'm safe. I'll finish that sketch, and I'll extrude that a 1/2 inch. So 0.5, enter. Oops. Naturally didn't create as a new solid, so it doesn't give me quite the look I want. There it is. And then I'm going to sketch one more time. Kind of throwing me around in a funny way. I'll project my geometry, then go hit my rectangle, and come down here, and there it is. Finish my sketch, and I'll extrude that 1.5 inches for the other 2x. I'll be sure to hit new solid this time, and let's take a look at what I got. So my rough opening's good. Now these are unsupported, so I'm going to have to add some jack studs here for this. To do that, the easiest way is going to be to sketch from the front and extrude in. I'll do that here. Now I'm going to go ahead and sketch on here the cross section of a there, and I'll drag that down to here, and that'll be 1.5 inches, 52.5. I'll go ahead and put one, I suppose, right here. At this point, and come down here, make that 1.5, enter. I'll finish my sketch, and then I think you'll be able to see this as I extrude these. I'll extrude this one and this one, and I will go in 3.5, and I'll hit new solid, which will add those jack studs, and they support that sill plate there. I'm then going to add a jack stud from the sill plate up to here. I do that with wooden frame windows. This would be perhaps controversial to some builders, would decide to scream and shout at me for this. They would rather not have this jack stud that supports this header sit on top of that sill plate, but run all the way continuous from the floor. I'm going to risk it because I don't think anybody's going to put me in Autodesk Inventor jail, but I do acknowledge that some builders would have an issue with that. I'll make this 1.5, enter, and I'm going to draw one down from this corner. That is 1.5, enter, and I'm going to go ahead and finish the sketch. I'll extrude these, and I'll go up here, extrude them inwards, and that, children, is how we frame a window. Again, there's an argument to be made that these could be run continuous from the floor plate, but thank you.